Hello everyone, so I hope everyone hears me correctly. So I'm a very literal kind of person, so this is a CSVconf. I'm going to talk about CSV a lot. So I come from a very weird little social sciences lab in Paris, which is named the Medialab. This is a research lab that gathers a lot of different profiles, so researchers in social sciences, engineers such as myself, and designers. And so we try to do a different kind of social science. And we have been building open source tools now for 10 years, and those tools are mostly geared towards social sciences, of course, and the civil society at large. So if you want, you can check out our GitHub. And so I have a CSV shaped question. So most, if not all, our tools are basically using some kind of CSV data at the end of the day. And we love CSV so much that we wrote a love letter to CSV. That you can read. There is the URL here. And so the question is, why though? Why CSV? Because I try to say to people on the web, I love CSV, and I was met with horror, hatred, guilt, and so on. So we are using CSV basically because this is an affordable, understandable, and free data format. So much so that CSV nowadays is a data lingua franca for our work, basically. So I'm going to try and explain to you why we are using CSV so much in the social sciences. So first of all, there is really good affordances. So basically, everybody is familiar with tabular data at some level. Here you've got some kind of spreadsheet, a very interesting one. Everyone knows how to read that and interpret this kind of information. If you give this to someone, so JSON data, nested data, I can't say this word, hierarchical data structures, they will frown. This is not really understandable. So this is easy to understand, this is not. So we are going to stick to tabular data so we can basically interact with our users. Then CSV is actually quite simple as a format, right? So the specifications holds in the title, so comma separates values, and I know sometimes you might want to use semicolons, pipes, and so on. I don't care, you use whatever you want. It's not, I'm not here to judge you, right? So it's very simple. Everyone here knows it's a lie. It's a bit more complicated, but you see the point. In any case, you can explain CSV to almost anybody very simply in mere minutes. Even more so, the format is so simple that you might invent it yourself, right? Or I think you should say you discovered CSV, right? I think a lot of people here invented CSV at some point in their life. That's all right. And then, of course, CSV is free, and this is very important. So nobody owns the CSV format. Or at least I think so. It is, and it will always remain and be a collective and free idea that was thought by many and is used by many. And it is so free that it has no real specification either. All right, I know about RFC 4180. I don't care about it, and I will fight you for it. And so it's so free that some scientific disciplines have their own dialects. Okay, so you can speak of CSV dialects, and I think it's very important. The term is tied to linguistics, right? So for instance, if you work in bioinformatics, you might be familiar with .vcf, .gff, and so on. And if you work in the web archiving space, you might be accustomed to .cdx and so on. All those are basically CSV files, right? So if you know how to handle CSV files, you can do a lot of stuff. And what's more, so it's free as in it's not proprietary, okay? So you don't need some non-free software to be able to read, write, process CSV data. So as a cheeky counterpoint, if you try to open an Excel file in your terminal or text editor, I know you all know that it will happen badly. And I know it's XLS, not XLSX, but you see the point. Don't open XLS files by yourself. It hurts. And so it's simple, it's free, and what's more, and this is basically a conclusion about that, it's just text, right? And text is very simple. You can write it yourself to some degree. Have you already tried to write CSV yourself? Yeah, I'm sure you had. You can read it yourself to some degree, somehow. And if I hand out some CSV to you, I give you the file and I tell you, this is some data, you should be able to open it and basically figure out what's going on very simply, right? And in 50 years, you should probably be still able to do so, which is very important, because in 50 years, I'm pretty sure that no one will be able to read XLS. Or how, at least I hope so. And so this means that in the end, CSV is a bridge, right? So CSV in our lab can be handled by both researchers, students, engineers alike. Everyone is able to process, produce CSV sheets and so on, and convert between CSV and some other format very easily. And so CSV is a bridge between what I call the spreadsheet world and the engineering world. So CSV is a good fit for both tiny and big data problem. Which is very nice. So CSV at the end creates the perfect condition for a de facto auto-organized interoperability of a lot of free tools that are designed by people all around the world. So this is a very good glue of data to make sure that a lot of people are able to work together. And so this was the first main point. CSV is very simple, CSV is free, CSV is text and so on. And what's more, CSV is sober. And I'm not sure the English term is very well chosen here because the French meaning of the term is a bit strange, but basically it's an austere data format and it's a very simple, affordable data format that is very concise, compressed, efficient, everything. So it's not exactly a chosen sobriety here, and I mean sobriety like in energy sobriety. So I work in the social sciences, and basically we don't have money, right? So we don't have hardware, we don't have powerful computers, we don't have GPUs. So it means that we have to get a little bit creative to be sure that we can do some stuff computationally wise. So, and what's more, our users don't have access to powerful software or hardware. Researchers in social sciences don't have powerful laptops. Students even sometimes don't have any laptops. So we need to make it do. And so what exactly makes CSV a good and sober, sorry for the term, data format? So it's a very succinct data format, like by default, naturally, because headers are only written once at the beginning of the file. If you read some JSON file, you will see that the headers are like the keys are repeated a lot. It does not mean that you cannot compress it very well, but basically CSV is like concise naturally. The strings are optimally represented. You will not like gain so much except for the quote. And the numbers could be lighter, but frankly, it's all right. So it's very succinct. And it's a very efficient format also. So the question would be, do you think you can reliably collect billions of tweets on the web without any databases, relying only on gigabytes of CSV data? And the answer is, of course, yes, you can. At least before the evil dude that I will not name arrived, right? So in our lab, we used to collect like a lot of tweets for social sciences, and we just like basically dumped the tweets in a tabular format within like heaps of CSV data that were compressed afterwards, and that's all. No database, nothing, just raw CSV. And it worked very, very, very well. So it can be thought of as a structured append-only log format, basically. So sorry for the engineering here, but it's very, very efficient. And so this means ultimately that you can take CSV and build a lot of different tools around them. And so I will showcase some of them to you. So some of the tools that we built in our lab. So we built dedicated web UIs for researchers and students. So this one is called Table2Net. And so basically you have a CSV of tabular data and you want to convert it in some kind of network or graph to use in Gephi or with Sigma. And so basically to map some network. So you can use it in the web, no installation required. This is one of our most old tools. This one is called Takoyaki. So it's a twist on like what is called the clerical clustering. So you are clustering CSV data and tabular data to find clerical errors to fix. So if you are familiar with OpenRefine, this is basically a twist on the cluster and edit feature. So still, web UI, no installation required, no server, nothing, just your computer. And then we also built command line tools. So for instance, here you have an example of one tool that is named minet that is running in the command line. So here we are taking CSV in and we are outputting CSV out. So here you've got an example of a command that is basically reading a very large CSV of URLs and that is trying to download them the fastest possible and emitting a report like with what happened and downloading the file next to the CSV file. So CSV in, CSV out. We've built other kind of CSV data, and we love CSV so much that we built like a tool to make sure that we can handle it from the command line, because we have a lot of CSV data. As I told you, we have like billions of tweets on the server, and so we need to be able to process them, visualize them very quickly. So we built this XAN, which is a fork of a tool that you might know, which is named XSV. And we also build libraries, like Python libraries, to be able to use CSV in weird manners that are not handled by the Python built-in modules. And the last point I wanted to make was that CSV also rewards out-of-the-box engineering and like clever thinking about how the format works. So I don't know if you know this one, but CSV can actually be read in reverse. So if you feed the bytes in reverse, it's still valid CSV. That's one of the only data format I know that is able to do so, which means that if you read the file in reverse and you like reverse the bytes and reverse the row order, hey, you've read CSV in reverse. That's crazy. So here, for instance, you've got an example of that in XAN. So the XAN reverse file, the XAN reverse command and the XAN tail command are able to read a CSV file in constant time, in constant memory and linear time, which is stupid, crazy. And then you can use this information to basically resume some stuff. For instance, you output a log, and then everything breaks. Everything breaks, and you need to come back to it. So you read the file in reverse, you find where you stopped, and you start back again. That's it. So my conclusion would be always bet on CSV. And I've made you a little flowchart if you need a database, all right? So if you need random access, use SQLite because you are a fancy person. If you don't, just use CSV, all right? And thank you for your time. There is some links for you to peruse if you want so. And I think I will finish here somewhat in time. Thank you very much.